I don't like the slop in the gear pedal, so I'm going to go about fixing that. I'm not happy with the play in this gear lever. There's sideways movement and there's movement associated with the play in this bushing at the end of the cable. Now there's a nylon bushing in there which I suspect I can pull out and replace, but the play in the main pivot is significant as well. That had new grease in it and new O-rings, but it's flopping around like a cock in a corridor. I want to see whether I can fix that. Now I've pulled out the 88, 89 footrest and immediately noticed a difference in this brake lever. I've got it here. You can see how this arm here on this one is straight to the pin. This gear shift lever is in this rusted footrest. It's pretty much seized in position where it's at, and you'll notice that this side where the cable comes on has got quite an offset in it. I think that's because on the 88, 89 the exhaust effectively ran through here. This was offset like that to miss the exhaust. Now the exhaust runs on the inside of this lever. This gear lever itself can't be just transferred across to my footrest, even if it is in good nick. I'm going to pull it out and have a look at the bushing in this one and see whether something can be gained from swapping just the bushing across, and maybe the bolt, but the bolt doesn't play. The bolt should be fixed in place and not rotate, but we'll see what this one's doing, see whether we can improve the gear shift situation. So I've got this footrest clamped up in the vise, and I've sprayed some CRC, which is like a WD-40, onto this joint. Immediately I can't feel side to side play in this pedal. Yeah, it's crunchy. It's been sitting out in the rain, I think, for 4 years. The bolt through the center of that, you see, does not turn. There's a fixed bush that the pedal rotates on, and that bolt holds that bush fixed. And then there's O-rings in the pedal itself which try to retain some grease in the joint. That other one on the bike is flopping side by side a lot, and a lot of up and down play as well. So let me pull this one apart. Hopefully that oil's had a chance to soak in to the thread. I have 4 gear shift pedals. This one is off the 94 bike. This one is off the 89 bike. That one is on the 90 bike. There's another one over on the 96 bike. Now what I'm suspecting is the actual foot pad is bent like that. The axle for the pedals like this, the foot pad is bent out like that on both of these. Axles this way, foot pads bent out that way. If that one down there is correct, the foot pad should be parallel to the axle of the gear lever. And also, looking at this one, that this part of the lever should be fairly straight, with one bend, and the pad parallel. So this one looks like it's got a bend between here and here that has cocked the end of that around. If this bend from here to here was straightened up, it would bring that foot pad back to parallel with the axle, which I think is the correct shape. Now this one has got a more complex problem. This part of the shaft starts off straight, but it kicks that way, possibly because it was bent that way at one stage, and then it's been twisted back. It's actually got a compound twist in the center of this pedal. In comparing these three with the one on the 96 bike, and I will sort of wander around here and show you a bit more of my shed. But the shed's a mess. I'm tripping over stuff to get here. This pedal down there has got a gear shift lever attached to it that I made, and you'll see details of that in one of my other videos. But yeah, it shows that the first part of that lever is pretty much at right angles to the axle, then it angles out, and then the foot pad is parallel to the axle. So I think that one is pretty much the correct shape as well. That one and the one on the red bike may well have been straightened or bent by me when I was doing restoration work on them. I'm not 100% sure of how any of them should be. One thing for sure is that this one is the 89 bike or 88 bike with the offset on the gear cable connection. So this one is the one I need to repair, and the first thing I'm going to do is try and bend it to the shape that I think it should be in. This is the bearing for the gear shift, and this pin here fitted a little bit more tightly. It's the one out of the 89 gear shift, and this is the 94 pedal, and you can see how much play that one has, and this pin's actually a larger diameter than the one that came out of here. I was thinking I might have just been able to swap the bushing over, but both of those have got way too much play in that hole. Now this pin, I think it measures in some places up to 12.7, which is ½ inch. It may have originally been ½ inch. It's a strange size to be seen on a metric bike, but tube sizes on the bike are imperial sizes too, so I'm not sure as to the reasoning of that, but it appeared that maybe this had started life as a 12.7 hole. This hole, this is a ½ inch drill, and you put that in there, and it's actually a reasonable fit. It's got play backwards and forwards. You can see this hole is elongated in the direction, you can see down on the top there, it's elongated across perpendicular to the pedal itself, which is where the pressure would come on. So that slot is elongated, which you'd expect with wear. Now that's a ½ inch is 12.7. This is a 13mm drill, and it goes in there most of the way, or at least part of the way. The pin that's been wearing in there is relieved in the centre, so it only bears on the last, say, 8mm, or you can see where the O-ring grooves are. So the centre part won't have worn in this hole, and that's perhaps why the half-inch drill fits without a lot of play in there, because it's bearing on the half-inch section, but you put the half-inch pin in and it flops around a lot because the centre's not bearing and the outside is worn. 13mm drill still doesn't take up the elongation in the worn sections of this, both top and bottom. So my plan is to, I can't get it to go right through, but there wouldn't be much stopping it going right through at the moment. The plan is to drill this, put this drill through this hole, probably just with the manual drill, and then use the end of it lined up in the milling machine to set this pedal up vertical with the quill as best as possible, and then run a 13.5mm drill through the hole. Hopefully that starts to clean it up significantly and makes the hole truer. And then I've got a 14mm reamer to ream the hole. So I'm effectively going to take about 0.5mm off the wall thickness, which I think will be fine. Hopefully come up with a nice, clean, smooth hole through there that's reamed out. I've got this brake, it's not a brake, it's a gear shift pedal set up in the milling machine in a collet. I think it's a 19mm collet. It's only gripping on a small portion of the tube there. I set it up with the 13mm drill to get an alignment, and so I've got the mill set to 0, 0 over that pedal at the moment. My mill has got CNC control on it, and you'd think, well, there's not a lot of use in this situation, but there are times when I'm typing in a Go G0 X100, which is going to move that drill 100mm away from the part when I press the return, as you see there. And I'm doing that just so that I can change the drill. I've just bought a new drill. I didn't have a 13.5mm drill. And this chuck has got up to a 13mm shank, so 13.5mm would struggle to go in it. So this is a reduced shank drill that ended up costing me nearly $42. So to go from 13mm hole to a 13.5mm hole is going to cost me $42. But I don't mind buying quality tools. This Sutton brand is probably the best available in Australia. I'll fit that drill up, and then I can type in the G code to bring the part back directly under the 0, 0 point so that I'm lined up to run this drill down. I'm going to change that instruction there when I press enter there. My part comes back under the new 13.5mm drill. I can start the spindle. I'm going to drill that by winding the table up rather than moving the quill. You can hear that cutting. I'm going to grab some cutting oil and complete that operation offline. That drilled through fine. just fairly small chips. The pedal's not held by much there, so I needed to take a pretty light cut. Going back to my MDI on my, this is Mark 3. I'm just using the up arrow key to select the go to 100 position again. I press the enter, and again you see that move away. Now this time I'm going to fit a reamer in the chuck. Now it's just a hand reamer. I may well be able to set the mill up to turn it at about its lowest speed, which is 60 RPM or 1 turn per second. With it turning at that speed, if I again raise the table, I think I'll be able to power a ream with a hand tap with it perfectly aligned, because I will just be shooting back to zero again with my CNC capability. Okay, that's the hand reamer mounted in a 15mm collet, positioned over the 0, point. I'm going to slowly wind the table up rather than bringing the quill down. See how that reamer goes cutting. That's a 14mm reamer, which is the finished size I'm wanting. Well, I've poked that right through there. I didn't show you the bit where the collet wasn't tight and the lower collet loosened, but my 0s were lined up, so it was only a matter of retightening those and beginning the cut again. It was starting to get tight and I could feel a bit of pressure on the lever, so I backed the reamer out, cleaned it and had another go, but I think I've got a pretty clean 14mm hole through there now. I found this bolt in the Chook shit. It was used to hold the extended tongue for the rear toe ball on the 94 bike. Now I've wire brushed that. It looks quite reasonable and serviceable as a bolt, whatever size it is. What I'm thinking of using it for is to make the pin for this gear shift pedal. I'm hoping the minor diameter of this thread is under 14mm. It's a bolt like this will be made, if it's high tensile, it will be made out of hard steel or hardened steel. I should be able to machine the threads off using a carbide end mill, and often the center of a bolt like this doesn't get hardened in the process, so you can usually drill it. I need to drill the center out 6mm. Both those operations will be trial and error because I don't know how tough this bolt will be. I'm assuming it's a high tensile bolt. I don't know from the markings on the end there what it is. First of all, I'm going to try and get an idea of the minor diameter of that thread to see whether it's a suitable piece of steel. I've machined the head off this bolt. The chips coming off were nice and blue, which means it's quite hard. The minor diameter of this thread is about 16mm, so it'll machine off, and I should be able to machine it to a tight tolerance around 14mm to fit inside the pedal. I need 45mm of it. There's a bit over 40mm of thread there, so I've got a little bit to grip in the chuck. I've made this pin, fits in there very snug. It's not finished in terms of O-ring grooves and the relief in the center. It's sort of roughed out at the moment. When I reamed this hole, I don't know whether we can see, yes, closest to the camera there's a dark patch up this end, and if I turn that around like that, there was another dark patch up this end where the bearing ran, because the pedal operates in that mode like that, and the wear the load on it would have been trying to elongate that hole to the north as that sits there like that. And that's where, even after reaming the hole, there was a bit of a patch that didn't clear up. The reamer, because this was set up in the mill like this, it's slightly bell-mouthed this end where the reamer fed in from. And so when I was fitting the pin, I found that the pin fits easily in this way and pushes right through. But what I've done is I've effectively ground the ends of this pin, this end being smaller, which was the non-bell mouth end, and this one being slightly larger. I think there's about 0.05 of a millimetre difference between those two sizes. My lathe turned a slight taper as it turned out, and after I parted it off, I then matched which end, because there was a relief in the middle of this, I matched the sizing so that each end fits, this end fits neatly there, and this end fits neatly this way. The net result is if the pin is put in this direction from this side, it goes in and is nice and snug both ends. That pin is got very, well, it's got clearance, it pivots. That pedal is now going to pivot very smoothly with no play noticeable at all. So I've repaired that. It's cost me $40 odd for a 13.5mm drill. Everything else I had the 14mm reamer, and I found that bolt in this pin has turned out quite satisfactory in terms of hardness. I could tell when I was trying to turn it with the lathe that very difficult to part it off. In fact, I couldn't part it off with my normal parting tool because it was so hard. I used an angle grinder and then faced the end back to the correct length. I'm having trouble turning these O-rings. I only had high-speed steel tool to try and dig in there, and it wasn't going to work. So I've dug the end of a carbide tool in there, hence it isn't deep enough. I'm going to go back to the lathe and play around with those O-ring grooves. The relief in the centre there, it's about the right length. It's a bit uneven because I turned it holding onto one end like that, and then flipped it over and held onto the other end like that. I think I can just smooth that centre out just for appearances. It's functionally fine. I've got a little bit of a countersunk in each end. I'm solving the pivot point problem with all this. Another problem that I've got to address is the wear on this little pin. Fixing that pin and nylon bush is a job for tomorrow. Get out to your shed and have some fun.